Hi guys, welcome back to another new video from Bioorganic Hub. This is Shayon. So in this video also, as like the previous, we will discuss a very important concepts of chemical science for CSIR NET. This is about Chaykovskii reactions. So the question was sulfur, double bonded C and COOET. As you can understand here, that this was the questions. So this is the allylic aldehyde and you have to figure out the what is the product. Now the condition you can see heating and benzene solvent. So first, to boost up your name reactions memory, let me know you that this reactions is called Chaykovskii reactions and is very famous in organic synthesis. But this is very uncommon reactions and this is an important dish for CSIR NET. So this is called Chaykovskii reactions. Now how to proceed for the reactions mechanism? First look at the reactants. You have sulfur, C and COOET. Now obviously this forms a stable ylide. What is ylide? You have, I think, heard about phosphoylide. Phosphoylide means phosphorus and another adjacent carbon will be hold opposite charges. So ylide normally applicable for those compounds which holds two opposite charges in a stable situations. Like this compound exists as a equilibrium with this compound. Here two opposite charges plus and minus actually coexist in adjacent positions with a very stable form. So what is the advancement of the molecule get by this arrangement? Yeah, obviously they get some facility by staying in this condition. Whatever the advancement, this you can say sulfur has a positive charge. So obviously this part has been now a good leaving group. S, CH3, CH3, CH3 twice S, good leaving group. And this part is a good nucleophile, minus, C minus, good nucleophile. So obviously you can understand the reaction mechanism will go in some way. This will act as a leaving group, sulfur, and this sulfur will act as a leaving group and this will act as a nucleophile. Now you have to figure out whenever nucleophilic addition happens to a alpha beta unsaturated carbonyl compound, whether it will form 1,2 fashions or 1,4 fashions. Okay, as like you have seen, I think, for my another video, Grignard additions, 1,2 and 1,4 fashions differentiations. This one also the same case. You have to differentiate whether 1,4 fashion will happen or 1,2 fashion will happen. Now one thing you can understand that this is the heating conditions. So this is a thermodynamically stable condition and it will take long time, and sulfur ylide, I am saying that this is a stable sulfur ylide. So obviously this will form, this helps us to make a statement that sulfur ylide actually is stable. So cyclopropanations occur majorly through 1,4 addition rule, because heating means heating suggests that this will give a TCP, means thermodynamically controlled product, with more stable product and more time and more reactions condition like heating. So this will give TCP, which is 1,4. TCP always happens 1,4 additions and the product will be thermodynamically stable. Now go back to the mechanism. This is the case. So it will attack here and this will go like this, this will go like this. This is the pi conjugation is going away. So this 1,4 addition is slow and irreversible, and this will form this type of compound. Now like the second step of Michael additions, this double bond will come here and this will make a good leaving group like this. This is a good leaving group, stable compound. So this will be a good leaving group. Now the answer is actually this of the Chaykovskii reaction. Now you have to figure out one more thing, that what is the stereochemistry of the substituent of the cyclopropane ring. Now to figure out that, we have to go through in the molecular orbital interactions. whenever this is happening in this carbon atom, actually a negative charge is forming. So this will forming a negative charge, which is carboanion. So this is sp3 anion, carboanion. So this is have a lobe in sp3 condition, which has been shown in figure by this one. When this lobe, this sp3 negative lobe, negative electron efficient lobe, will make an overlap with the CS sigma star and make the cyclopropane ring. Now, to make a stable intermediate, obviously you can understand this CHO and this COOT, CHO heavier or bulkier in this side, COOT bulkier in this side, will be situated as far as possible. That's why if this CHO will be upper, COO will be below the plane or in the plane. So in reaction conditions, you have to figure out and remember this thing, that CHO and COOT group orient in space so as to minimize in repulsion. Hence they assume the transposition. So this is the 1,4 addition. You have to remember this happens for the 1,4 addition, and this will happen by 1,4 addition manner. This is the 1,4 addition, and orbital overlap will show that intermediate will such a way that this CHO and this COOT will be as far as possible. That gives a trans product. Now, if you think in a different way, what will be the product for a 1,2 addition? Obviously here 1,2 addition will not happen because this is the heating conditions and stable halide. So 1,2, but KCP 1,2 or KCP can never happen. We all know for 1,4 addition will happen for heating conditions and stable halide. Now if 1,2 addition happens, what will be the case? This is the case. This is for 1,4 it was 1, 2, 3, 4, but for 1,2 this was 1 and this was 2. So it will attack here and create this type of intermediate, which will again attack here and make the cyclopropane ring, but with the oxygen for the now, as compared to the previous case was only cyclopropane ring, but this is actually a oxygen ring or epoxide ring, and the leaving group is same. Now epoxide form when kinetically controlled product we are targeting, like 1,2 addition. Now why not it is the major product? Why it is the minor product? That we have to think about. So since 1,2 addition step, you can see this is reversible step. This is the main cause why not 1,2 addition is happening. So 1,2 addition will not happen because this is the reversible, and expulsion of halide, expulsion of the halide from the intermediate is also more likely. Expulsion of halide is more likely. However, for 1,4 addition case, step is irreversible, as you can say. Step is irreversible. Okay, that's why this is the major product. And in this case, CO is forming for 1,2 addition. And you know, for any reductions like hydrogen palladium reductions of CS, carbon sulfur, so carbon heteroatom bond is not at all stable. It can be easily reduced by hydrogen palladium. So if it be reduced by hydrogen palladium, such a small reagent, then why it will be stable? You can understand. It will be much less stable than CC homo bond, than a C oxygen, C carbon, C sulfur hetero bond. So carbon heteroatom bond is not at all stable. That's why this epoxide is less stable than the cyclopropane ring, this one. That's why 1,4 addition step is irreversible due to formation of stronger CC sigma bond. The equilibrium moves towards the 1,4 addition step intermediate, and final outcome is the formation of cyclopropane major product. So when 1,2 addition will be the major product, obviously you can understand 1,2 addition will be the major product when sulfur halide is not stable. We have said sulfur halide is stable, and high temperature means long reaction time gives 1,4 additions. So our take home message is, if for Chaykovskii reactions, if some longer time, some hard conditions like heating is given, and sulfur-ylide is enough stable, then you will end up 1,4 additions. And for 1,2 addition only will happen when you have unstable ylide. And you also understand that 1,2 addition is not stable because of reversibility, not is the major product because of reversibility, but 1,4 addition is stable and major gives the major product because of irreversible formation of CC, strongest bond, cyclopropane ring. Thank you for watching.